In this session, I'm going to show the difference and the interpretation between ARCH effect model and GARCH effect model. The data is start daily data 1990-1999. The variable is stock return, which is R. Because we are using multivariate model, we use only one variable at a time. There shouldn't be any missing data. Most of the financial data exhibited any one of or more of the following features: volatility and clustering. Some periods are high volatile while others are less volatile. Or big shock for residual tend to follow big shock in either direction, and the small shock are follow small shocks. This is apply a strong autocorrelation. ARCH model are highly useful in many situations where the prediction of volatility is important. For example, assets holder want to forecast both mean and variance of the return. The mean equation is forecasting it means the forecasting equation. R equal MT equal the error UT. R is the actual return, MT is the mean return or the actual mean return, and the UT is the actual return from its mean, which is the error term. Variance equation of ARCH says that the variance of the error term at time t, called as conditional variance, depend on the square root term u square t minus 1 lag 1 of the previous period from previous period. As you can see, this is the formula. The variance at the present square, the constant a, or we call it the mean, average mean, or the mean of the equation, and b ut minus 1 square, the error term square, which is the ARCH term, and up to b p your error term square lag 1. So in this case, if ARCH P model where the number of lags is chosen based on the convenient criteria, the null hypothesis B1, B2, BP equals 0, and the alternative not equal 0. Now the steps we are using here to perform the ARCH and GARCH model. First, we open the data, as you can see it here. Daily data 1990 to 1999, which is 2610 observation. Step 2, run the ordinary least square method or model. We use the model, the stock return R constant, autoregressive AR1, and MA1, which is the mean average or moving average, and this is, we call it ARMA 11. Then draw the residual from the view and test for ARCH effect. If ARCH effect present, then estimate GARCH effect model. If ARCH effect not exist, then estimate ordinary square, and then test ARCH effect model with interpretation, then test GARCH effect model with interpretation, and compare ARCH with GARCH effect model. Then we have to start with the EViews. Now I'll go to EViews. As you can see it here, the data from 1990 to 1999, 2601 observation. I open the data as in the step, then I'll go to quick estimate equation. I'll put R constant, AR autoregressive 1 and MA moving average 1. We call it ARMA 1 and then we run the regression as ordinary least square, as you can see it here, and press OK. We are not interested in the interpretation of the ordinary least square, rather than we are going to test the diagnostic of the ARCH model and to see whether ARCH model is exist or present in the model or the residual or not. In this case, we have the hypothesis, as we mentioned, the hypothesis here. If null hypothesis, it means ARCH effect, there is no ARCH effect in the residual, and the alternative, there is ARCH effect. Then I'll go to draw the graph, actual or from residual. You can see here the graph. The red is the blue is the residual. The line here in the middle is the actual, and the line here, the fitted line here, as you can see it, this straight line, and the actual line here. Then after that, I have to test for the ARCH effect, whether it exists in the residual or not. I'll go to View, Residual Diagnostic, Heteroscedasticity, select ARCH, press OK. You can see here PR, observed R square, corresponding to p-value of chi-square less than 5%. This means that we have to reject null hypothesis. What is null hypothesis? Null hypothesis, it means there is no ARCH effect on the residual. But now when we reject null hypothesis, it means the model or the residual has ARCH effect, then we have to go and apply GARCH model. And this is to fulfill the requirement of the ARCH model, we have to reject null hypothesis, and then we move to GARCH model. Then I'll go to estimate. I have to estimate ARCH model. I go to estimate. This is the variable, as you can see it. The option here, leave it as it is, the specification. Then you go to ARCH. When you go to ARCH, here we are running ARCH model. Put GARCH 0 because ARCH 1 model and GARCH 0. The option is, I'll go to EViews legacy, leave everything as it is, and go to specification, then press, of course, here you can use normal, student, or GED. In my case, I use the normal student. Let me put student, and then click OK. This case, this is the outcome. This is the main equation. We are not interested in this main equation, whether significant or not, and we are not going to delete any of them because we are interested in the variance equation, which is here, this one, the equation. And here, what is this equation here? As you can see it here, this is the equation, ARCH equation, sigma square t, the variance, ut, error term lag 1 square, actual return from it is mean error term, alpha is the constant represent mean return in ARCH model, and beta is the coefficient of the error term in the previous period. While GARCH model represent, this is the ARCH term and this is GARCH term, and this one here we call it the variance of error term. So we are using the, as we mentioned here, this is the ARCH model. In the ARCH model, we are going to concentrate, are not going to explain in details what is the outcome for ARCH model, but we are going to test. As you can see it here, the ARCH model, what represent? Here we have 0, 5, 0, 7, 4, and as you can see it here, and this is beta, which is 0.135. As you can see it here, I put it here, the model, this one here, 0. Sorry, let me just check it. 0.35, 0.135, 0.135, and this is the ARCH model, and the hypothesis is there is no ARCH effect or no volatility clustering. The alternative, there is ARCH effect. Then here, because we have only one variable, which is the error term lag2, lag1 square, so you add the GARCH model. The model improved so much, which is a significant improvement in the model. So to compare both model, ARCH and GARCH model, you will see the result improved with GARCH model than ARCH model volatility clustering. Then we have to go to GARCH model. As you can see, this is the equation for GARCH model, and this is the variance of error previous for a previous period. And then I'll go to EViews, then I'll go to change to ARCH, GARCH 1, ARCH 1, GARCH 1, and then press OK. Here you can see the outcome for the variance, and this outcome here in the equation, you can see it here in the equation, alpha equal 0.000000625 plus the coefficient of the ARCH term, residual square lag1 0.046, and the GARCH term represent 0.946, and both of them, they are statistically significant to predict the return of the stock return. As we can see it here, I put it here in the equation. As you can see it here, this is the equation and this is the outcome. As you can see it here, 70625. Let me just 1 2 3 4 5 6 7 6 2 5. Okay, 625 here. Okay, 625, and the beta for, okay, just put it subscribe, and the variance of the error term lag1 square, here you can see it here, represent 90, this one here 94.65, 94.6, and then because this is, I was practicing and I put different number as a result, and here then 0.046, 0.046. So in this case we have to calculate it, and we can see that 0.94 plus 0.046, which is equal 98, as you can see it here, 98.6, and this is here 46. Okay, this is 46, and beta 2 94.6, and the total is 98.6, which is 98.6. And here we can see that the sum of the coefficient beta 1, beta 2 in the equation, as you can see it here, beta 1, this is C or alpha, beta 1, beta 2, the term, ARCH term and GARCH term, and this is the constant, and this is alpha, beta 1, beta 2, beta 1 plus beta 2 equal 98.6% and statistically significant. This means that the coefficient B1, B2 or beta 1, beta 2 less than 1% or less than 1 or close to 1, which means that the shock to the additional variance will be highly persistent. Since the GARCH barometer is significant, as you can see it here, it is both of them significant. A large excess return value, either positive or negative, will lead to future forecasts for a variance to be high or a prolonged period of time. This means the GARCH model will be a better forecasting model than ARCH model in period of high volatility. Then from this part here, if we subtract this one from 100, so what we have here, okay, 0.986 minus, 100 minus 0.986, so equal 9.9. So here we can say there is the beta 2, as you can see it here, beta 2 greater than beta 1, and here beta 2 greater than beta 1, and then the remaining is 9.9. This is the taking rate, which is when we say beta 2 greater than beta 1, the regression here, beta 2 greater than beta 1, it means that resistance. What is the resistance here? Resistance means that if the market off, it remains off for some days without any reason. Even if positive news come tomorrow, the market remain volatile. From the outcome, one can see that both ARCH and GARCH parameters are highly significant when p-value equal almost less than 5%. Okay. Then after that we have to go and do the diagnostic. How? I go to view, residual diagnostic, correlogram, Q statistic, leave the lag 36, press OK. Then we can see here all the data, all the p-value greater than 5%. What does it mean? Because Q statistic here high and p-value high greater than 5%, meaning that the null hypothesis, if p-value greater than 5%, it means we have to accept null hypothesis and reject the alternative. So what is null hypothesis? Null hypothesis, there is no serial correlation in the model. So in this case, all p-value greater than 5%, so we can accept null hypothesis and reject the alternative, meaning that there is no serial correlation in the model. And then I have to check again residual correlogram, square residual, and press OK. You can see all the probability is greater than 5% when the Q statistic value is high. It means that all the p-value greater than 5%, so we have to accept null hypothesis, or we cannot reject null hypothesis. Rather than we accept null hypothesis and we reject the alternative. This means that the model is free from serial correlation. The last option for last diagnostic we have to test, we go to ARCH LM test, which is, we leave it there. You can put it because we put 2 lag for ARMA. Then you can see here observed R square corresponding to p-value of chi-square 37.37%, which is greater than 5%. This means that we have to reject the alternative, and we cannot reject null hypothesis. Null hypothesis meaning that there is no arch effect in the model. So we are now happy about this model. There is no serial correlation in the model, there is no arch effect in the model, and the model is free from both of them. Thank you very much. Please don't forget to subscribe for more video coming up. Thank you so much.